Okay, so this is part F on the progress check because a lot of people are messing this one up. Okay, so this was out of 3 points. Okay, so it does have some calculus in it, this one, but you could have gotten at least one of the 3, right? Even without doing any calculus. Okay, so I forget, what does it say? After landing, the skier slides along the horizontal ground before coming to a stop. Okay, so here he is. Right, he's skiing, and then he's gonna, oh, he has no body. That's kind of weird. Okay, and now he's gonna come to a stop over here. Okay, and this V, they said, was the same V from, I forget what part it was. It was 42, whatever was that one. 42? I can't see, it's so tiny. Whatever that one was, okay? I think the X, I don't remember what they said. Horizontal component of the skier's velocity when I left the ramp. Oh, so 42, yeah, was his real velocity, okay? So they said his velocity here is just Vx, okay? All right, so what you're really trying to do, right, if you want to just think about this, right, he's going to have some kinetic energy here, and he's going to come to stop, okay? So you can either draw it, right, the work done by friction out, okay, or you could have called that 3 boxes, that's too many, 3 boxes of E therm, okay? Either way, you're basically trying to set the kinetic energy equal to the work or the E therm, okay? So, you know, you could have gone like K minus W equals 0 or K equals E therm, something like this, all right? Okay, so I'm going to have 1/2 mv squared equals the work, which is the force of friction times the distance, okay? So a lot of people kind of got that. All right, I know the M, I know the V. I'm looking for D, so I need to know the force of friction, okay? So a lot of you did this, right? You did mu Fn, which was correct. And then you did mu mg, which was correct, right? Because there's no other, he's not on an angle or anything, okay? Now, this is where you have to do the calculus, okay? If they had just said like mu equals 0.2, you would have just plugged it in right here and gone about your business, okay? But it's 0.2x, okay? Which means that it's position dependent. It's going to change, right? The longer he slides along that surface, that coefficient of friction is going to keep increasing. Okay, so whenever it's something that you normally think of as a constant and then it has some other like position dependent or time dependent or something, that's how you know you have to use calculus, okay? Right, so what we have to do then is 1/2 mv squared, okay, that's the V initial, right, because that was the initial kinetic energy, okay, equals, how did they do that? Whatever, they have a bunch of negatives in there. Okay, I'm going to have 0.2x mg, okay? And instead of d, right, this is where I have to put dx, right? Because I need to relate this to this, okay? So basically, I have to, every little tiny amount of x that I go, this is going to change this, okay? And so you're taking the integral of that, okay? So basically, instead of work is force times distance, you're saying work is the integral of force times distance. Let's see if that was called x, right? So f dx, right? So anything that's multiplied like this, you can turn into an integral by putting a dx a little tiny bit, and then you're adding them all together, okay? Which is in effect what you're doing, okay? All right, so even if you don't know integrals yet, okay, you always want to pull all the constants to the front. So that's going to be 0.2 mg, and then I just have the integral of x dx, okay? And then that 0.2 mg can go to the other side, okay? So that's going to be 0.4 mg, and then the m's can cancel. I hope that's right. It's so tiny, I can hardly even see it on there. Is this going to be right? Well, I guess we'll see when I get the right answer. If not, I'll have to re-put. Okay, and then you get this. All right, so even if you don't know integrals yet, right, basically what I want to do is I want to find out what would the answer be x, what would the original be if I took the derivative and it was x, okay? So I know it's going to have to be an x squared, right, because when I take the derivative, I'll get x. And then if I had brought that 2 down, I need it to cancel out, okay? So I basically get that. So v naught squared over 0.4g times x squared over 2. Okay, and then I evaluate that integral from when the position is 0 all the way up and until it's that distance d that I'm looking for, okay? Or x or whatever you want to call it. It doesn't really matter, Okay. All right, so now I can solve it. So I have v naught squared over 0.4g equals x squared over 2, or d squared over 2, okay, depending on whatever you want to call it. I'll just call it d, I guess. All right, and so then d equals 2 v naught squared over 0.4g radical. Okay, and please, I hope this is right. Okay, so this was 40. They said 42. I thought it was like 40. Oh, because it was 42 as it left. Okay, cos theta, which was 25. That was the x component over 0.4. They used 9.8 in this one, but, you know, you could probably get away with using 10. And let me just double check to make sure I did this right. 2 times 42 times cos equals divided by 0.4 divided by 9.8. Please be right. Oh, it's not going to be right. What did I do wrong? Radical. No, that's not right. Okay, let me just make sure I punched it right. Okay, it's supposed to be 27.2. So let's just pretend that worked out, because if it didn't, I have to record it over again anyway. So you can probably stop the video here while I just make sure this is right. Oh, I used the wrong angle. That's what happened. Cosine times 42 times 2 divided by 4 divided by 9.8 equals, nope. My God, I need a real calculator, not my iPhone. Stupid. Divided by 9.8. Uh-oh, this is not right. Okay, what did I do wrong? Okay, forget it. I gotta start over now.